Welcome everybody to this meetup session. I hope to have a very engaging session with you. This is the topic today, harness LLMs, especially in the context of beyond going with travel bookings, and that's the typical translation stuff that we see. How do we harness it as a part of enterprises, right? So that's the idea. I'm sorry, keep pausing me for time checks. If you see I'm going too off. Yeah. This is me, Joe. I'm the speaker today. I live in Chennai, so does Ansari. And but I have also lived abroad for some time. And in fact, I moved to India only a year ago after I joined Cloudera. I have been here about a month. If you haven't heard of Cloudera or haven't engaged with its products, check out the website, check out opportunities to work here. Pretty cool company. I've been very happy here. I've been working in a few other places before this, in different roles, lots of front-end customer-facing experience. I've a master's in administration, but I choose to live on the side of engineer than the side of the business guy. So that's a choice I made. So I'm more tech deep than PowerPoint deep, let's say that way. But today a lot of it is going to be on slides. So yeah. I think the agenda today is going to be fairly straightforward, right? We know, or if we are here today, we want to learn something and we want to know what this is about. Unless we have been living in a rock, this has hit us like more deeply than ever in the last 2 months or so once ChatGPT 4 got released. So we'll talk a little bit of what this hype is about, what's the big tech underneath, what's going on. We'll also use this to understand, uncover the onions a little bit, or I'll peel the onions to understand what's going on underneath. And then I want to talk some things about how do you set this up for your enterprises, but what risks and concerns you're going to have, right? How's that for expectations? Any specific topics if you guys are having while we are going through the slides or at the end? I'll try to keep it like an hour or so or less than that. And then in case we have any issues or questions, burning questions, just stop me right away. Yeah, that's me. So that's Vish and that's Cloudera. Okay. So just sort of to set the context here, if you have not been living under a rock, then generative AI is something that you get to see or hear, or and it's impacting us around a big way, right? So in fact, if you are working in a company or going to use this in an enterprise, then this is a hot technology, right? There are lots of quotes around, lots of investments that's happening around this space, and therefore it's a hot field to be in, and at least a hot field to learn a little bit more about. What's happening is, we hear about these things a little bit nowadays, but this has already impacted content development. So it's not like, okay, it's a totally new story. It's not like landing in the moon. It's something that has happened, right? If you have not had a chance, I would ask you to try Mid-Journey and just give a couple of texts on what you want to generate. In fact, some of the images that I just have generated here in this presentation have been used using generative AI, right? So I'll talk about them when I see this. But it's not about text, right? It's also about video generation. You can also use it for customer operations. So there is a McKinsey paper, which I encourage you to read, which talks about how customer ops is going to get impacted with generative AI. So it's coming, right? If it's if you haven't seen or thought of some of these topics, then it's coming to us. If you are a coder, it's definitely there. If you haven't seen GitHub Pilot, have a look at it. It allows you to complete your test cases or your documentation. So lots of stuff happening here in this space. And why is this happening? And what's the big driver behind all this hype is also about how sophisticated these models are. So large language models have been around for a while. Generative AI also has been around for a while. But if you see the speed in which the models have become sophisticated, right? So if you say ChatGPT, which got released around 2019 and 2020, it had a lot of development time behind it. But from that point, ChatGPT 3 came around in 9 months, and now you have the GPT-4, which also came around that time, right? And as a parallel to this, there have been lots of open source work which has also happened in LLM space. One thing to understand, right? Large language models are different from your conventional models, and the word large is there for a reason, because of what you see in the brackets here. Sorry if it's a little small to read. That signifies how many parameters you are holding in memory, right? So if you are holding, like when we started GP2, it was about 1.5 billion parameters. And now if you take, it's just billions, it's just exploded, right? So imagine all these parameters, a parameter that is required to give an inference in a model has to be held in memory, or part of it is in memory also, can be possible. But that's how large language models are set up. And this has also given rise to a lot of VC funding. So if you are in any of these industries, from automotive to pharma, there is no escape. You are going to get hit with it with a variety of use cases. But I wanted to sort of take a step back and do a machine learning and 101 thought process, right? So if you take a normal problem in machine learning, which is saying, okay, given some text, I want to understand in Twitter, somebody's posted something, and you want to know, okay, what kind of text is it? Is it like a positive text or a negative text? It's a classic, what is called as a classification problem of text. How do I define what the text is? And this is typically, and you can say, okay, this can happen in a few, not necessarily in 7 months, can be done sooner or later, depending on how big the volume of data I take. But this is the process you follow. It is called as the machine learning work. Right? You take a labeled data, so which is saying, okay, this text, I did not know I would like the movie so much, but I did. Is what? Maybe somebody can volunteer. Is it a positive user sentiment or a negative? Somebody from the audience?
Negative.
Yeah. So how did you know it's negative? I did not know I would like the movie so much, but I did. So what would you say it is? Did you like the movie so much? Or not? So it's, again, how do you
dislike? I dislike the movie.
You're saying it, you dislike the movie.
Okay. Yeah, the rephrase.
Yeah. So again, we can take a little debate on saying how exactly the verbs and nouns and negations are placed in the sentence. But essentially, what you are trying to do is take a judgment and say, based on what is written here, I dislike the movie, or whatever, it's a negative sentiment, and somebody says it's a positive sentiment, and so on. And based on different phrases, you get this labeling of the data by a human. Then you train an AI model on this, right? So some way you represent this in a mathematical way so that the computer understands that when I give it a new phrase, I dislike the movie, or I did not like the movie so much as much I thought I would. It would then be able to classify, hopefully, and say, hey, this is a positive sentiment or negative sentiment. And finally, you deploy the model, and the model will get posted in production, and some downstream application is likely to, just some setting is happening here. Okay. So that's the reason why you can then go and say, okay, I can deploy the model, and then the model will get consumed by another system. So what's the big change now that's happening? So if you take the big change, sorry, I skipped the slide. The big change that's happening now is that this training step you see here is missing, right? It's gone missing. Now you are saying that it's going to get replaced by something which you are able to do much faster, which is adapt the model much faster. So here's what I did, I can show this today if required, but here's what I did. I said, hey, large learning model or model, I'm going to give you a set of prompts. I'm saying, if my statement is the movie was horrible, my sentiment is negative. If the movie was the best movie I watched all year, my sentiment is positive. It's a disaster, negative. So then I specify that when you get a new text, please classify the sentiment based on these set of promptings that I have done, right? And we'll talk a little more about what prompting is and so on. But at this point, this is enough, right? So we just say, I prompt the system, and then it gives me an ability to give an answer. Note the missing step here. The 3-month step or sort of is gone, right? I don't train the model. I just take the model, what is trained by somebody, and then use it directly to adapt it to my purpose. And that's really what a large language model does, right? The large language model is a foundational model. It's a foundational model. Is it different from other models that you have seen. It's different from a forecasting model. It's different from a classification model. It's different from a prediction model. Why? Because it's been trained for a variety of data. So it can be trained on text. Some of them can be trained on text and images, can be trained even on speech. And it's the same model. It's got just different data associated with it. And then it has been adapted for a wide variety of tasks. So you can use, fundamentally, you are taking the same model, and then you are using it and adapting it to a wide variety of tasks like Q&A, something like we did sentiment analysis, or you can also talk about image captioning, saying, okay, this is a cat, this is a dog, or something more sophisticated, and doing some things like, okay, this is a pyramid. What kind of object is this, right? So those kind of. So that's the core to what large language model is. But if you have been so far, I think some of you may have already seen or heard of some of this. But then there are some moot questions to this, right? Why are these models adapting faster? Why am I able to entirely skip this whole step of training the model and still able to get a model response reasonably? You know, what are prompts? We talked about prompts, and what makes this whole process different, right? So let's go into a little more deeper, and I'm going to get a little mathematics-y or trying to get a little technical. But just it's important for us to get a foundational view of what is it that we are dealing with when we are saying it's generative AI or large language model. Okay, let's take a question, right? And basically, large language model or whatever language models are doing one thing. They are going to give a prediction. So when you are giving it a sentence, it's giving you an answer. What it is doing is generating these predicted word one at a time. So when I say, give me an answer to what is the answer to the universe is, and it's saying, I have given the text in here. It's going to understand the context of these words and then going to try to predict what is the next word, right? So how does it do this? So this is how we can do it if we are writing it in code, right? So you say, okay, here just some things to understand, right? BERT model is a standard open source model. And if you remember the question that I asked, the answer to the universe is, when I say mask, you can ignore other things, right? This is a more code specific, but just take the high level first. So if I say the answer to the universe is mask, what I'm telling the model is, hey, please give me an inference or give me an output and fill this mask for me with whatever you have been trained on. And based on that, internally, it goes back and comes with a bunch of things that are responses to the model. So the responses can be a number of things based on the answer to the life is simple, the answer to the life is unknown, and each of this it is predicting with a certain score. So it's saying, this is a score for the word unknown, this is a score for the word simple. So going back, the answer to the universe is no, nothing, yes, unknown, simple. And each of these have a certain level of prediction with it. And typically the model will take the highest prediction based on the training data that it has been trained in and give you an answer. So this is, an oversimplification that once you have the answer to the word is unknown, then you have a whole sentence, then you can predict the word after unknown saying what is the next word and what is the next word and so on. So at the heart of generative AI is the context of probability distribution of the next word. But I wish it was just that simple, right? I mean, if you say languages, again, languages are funny, right? Somebody has said English is a funny language. And here is an example. So you say the student, and by the way, this is, the image is generated by generative AI, just to keep in spirit of things. The student, besides taking up piano lessons and engaging in cultural events, was interested in maths, right? So the student was interested in maths, but the students were interested in maths. So remember, we talked about the word prediction. So when I'm at events and you're asking the generative model to predict the next word, it has to predict were as the highest probability, or it has to predict was based on the highest probability. But what is was and were dependent on? Maybe somebody can guess based on the hints here. When I predict was, what should I pay attention to? Should I pay attention to besides taking the piano lessons or something else?
Or
what should I pay attention?
The individual, how many individuals
is important determiner in the singular word was or were.
Student and students.
Is the question clear? Because this is very important. when I'm writing was here or when I'm writing were here, what determines should I be writing or predicting were or was?
Number of people.
It is determined by the word student or students, right? I can ignore everything else and this sentence can be a paragraph long, but still it has to be was when it's a student there, or it has to be were when it's the students there. There is no other way the language can be right? So when I'm doing this in a computer-generated prediction, my attention has to be on certain words. It cannot be equal across another. So that is what is called as the big difference in language models, that they have to pay attention to certain kind of words more than they are paying attention to some other. And these are classes of models are called as attention models. Let's try one more example here. So is he opening the window or closing the window? Any guess? He could be doing either, right? You don't know. So if you try to write this in German, I chose this because I lived in Germany and I find the language very funny. So you can say, okay, in English, the word student or students depends only on the prior word, was or were. But in German, it changes. So in German, you say, mag das Fenster auf, or the mag das Fenster zu. The word aufmachen is opening the window. The word zumachen is when it's closing the window. But when I'm translating this from German to English, and I say, okay, is he, and I say mag, okay, I can't decide yet. It's just opening or closing. I have to go right till the end and figure out which is the word here, auf or zu, to decide whether it's opening or closing the window. So the point is, again, that you cannot always say, okay, the prior word, I can place some importance on it and decide. It depends on the language, right? So these are some of the things that really is what sequence models are about. It is about context and it's about memory. So I need to pay importance to some contextual words and I have to hold them in memory to decide the prediction of the next words. And that was really what a lot of neural networks were designed earlier. They are called recurrent neural networks, GRUs, long-term memory, something else. I forget what this is. But these are the classes of models that were earlier built for all these kind of tasks. But they had issues in terms of, okay, if I now start taking big chunks of text, will I have memory overflow issues and scalability? So something happened on 2017, right? A class of researchers came out with a seminal paper, right? So anything that you are seeing today, hearing today in large language models, in foundational models, traces its attention or traces its origin back to these words. Attention is all you need. If you don't know anything else about attention models, this is something you should remember. These guys fixed the problem that were stability issues around these, and all variants or most variants of attention models that you see today or language models you see today are based on the attention architecture, which is like in a simplified way based on what I told you to just now in German and English, right? So that's the first thing. Now you say, okay, I have defined the model. Is my problem solved? No. Why is that? The issue with language models is, even though you are saying it's a large language model, it doesn't understand language. This is the oxymoron. They don't understand language. It's a computer representation, which means it needs numbers. So every single word that you are going to use with ChatGPT or any other form of language model needs to be converted to numbers. And that therein starts the problem. How do I convert English vocabulary, which has about 400,000 to 2 million words, uniquely, so that each of these words are understood by the model in a certain way, right? So a number of approaches were tried here. So, I mean, I'm not going to go into too much details on matrix algebra, but there were a number of approaches tried here, right? So they said, okay, can I change a word A into a matrix of 400,000 words, where each of them are represented by a binary. So I have a matrix for A, and then a matrix for my happiness, and so on. But problem is, look at the size of this. For one word, I need 400 by 1 size matrix. So imagine a document of million words, 400,000 by million. Impossible. So hard for all this to fit in memory. So then somebody came up with a very smart way of representing words, which made it much more compact so that you can represent each words in a much smaller size. There was a second huge advantage with it, right? It taught systems, computer systems, associations. What do I mean by that? When we think of something like king is to queen, and then we say boy is to, in our human mind, we are able to come up with the word girl, right? How? Because we are able to associate. Human brain associates. But in computer, this combination is hard because, what's common between dog, cat, and fish is they all go to the root of animus, biotree, right? And apple, grape, and orange go back to the root of fructus. They don't look anywhere same in shape or size or form or color, but its roots are same. And that roots is fructus, right? So this way, you are able to teach the computer to group together certain and build together some associations. But why is that important? It is important because these similar words provide us better context, right? So when you say you want to talk about happiness, you can say directly happiness, but you can also talk of associative words. You can say, okay, wealth can be, it's debatable, but wealth can bring me happiness. Pleasure can bring me happiness. Mankind is to some extent happy. All these have some associations, right? So if you go to TensorFlow, for example, in Google and try to type some vector embeddings, it will tell you based on a certain word, what are other words which are close to it, right? In contextual sense, based on the different models that have been trained on. And why is that important? It's important because now we are going to, for large language models, there's a third concept that we need to understand, which is a new class of databases called as vector data. So you say, okay, now I have enough of it, right? Which is talking about so many theories here. But what's a vector database and why is it needed is key to understanding how language models work. Because a vector database stores data. Like if you take a student database, you say, okay, student number 1 is Vish, is in, 5th standard, is studied in this school. But just a student ID is able to give me so much information about me, right? This is different. It stores data in groupings, just like we talked about earlier, so that when I tell the vector database, just like UK is to pound, what is rupee? Then it is able to go back and say, okay, you talked about UK and pound. I think UK and rupee, India and rupee go together, right? So it's be able to build these associations together. And that's really what you should understand. And these are some examples of what you will likely to see. In fact, we'll see Chroma database today, if we get a chance to see the code, on how data is organized in terms of associations or semantics. So now, finally, we are talking about the end-to-end large language model. So how do I build one, right? So we collect a lot of data. This is how typically large language models are built. It collects lots and lots of data, different forms of data. You saw it's a foundational model, right? It can take different sorts of data. Then it builds what I called as vector embedding, which is nothing but a fancy way of just doing what we just saw, taking a word and converting it into a number so that the model can understand it. Finally, it takes the attention model we talked some time ago and trains the model. Now, all this is done. My model is ready, but my model is ready in a very generic way. I wanted to train it for a classification task. Talk to me about text classification to identify movies good and bad. That's called fine-tuning the model. And then you deploy the model and say, okay, finally my model is ready. So this is how you build an enterprise large language model, or this is what you see when any of these models that you hear today, right? ChatGPT, Llama, whatever. This is how it gets built end to end. Now, what's the issue here? The thing is, what's the difference here? We just have the large language model. So PaLM is a large language model which has been recently, or not recently, but some time ago built by Google. And it works like this. You define a prompt and you get a response. That's it. You have not trained anything. You've taken a built-in model and got a response. So now what is this prompt? Let's take a little look at what is this prompt. You ask it a question, what is quantum physics? And based on how all this we saw, right? Word prediction and vector embeddings and it comes out with a response predicting based on this question what the text should be. Each word is predicted one at a time. No difference here from all the theories. But then, let's change the response up slightly. You say, explain like a 5-year-old what is quantum physics. And it has to completely come up with a different prediction. Because it's now, you are asking it to be smart and reword its response. So, as I said, again, the prompt is this ability to tweak a response of a large language model based on what you expect it to give, right? How you expect it to give. And in case you are looking for a job, this is the next big job, right? So all those data science predictions, data being the next oil, data scientist being there, it comes right up there. Because you don't necessarily need a computer science engineering, but you need a way to construct different formats of prompts to optimally extract the response from the system. So this is just something to think about if you are looking for careers. But like with all systems, so maybe I can just take a brief pause here to answer like 2 questions that we then hold again some question time at the end. But based on what all these things I saw, I talked about now, any questions? Like I said, folks, we are learning from each other here. All this is new space. So no questions are dumb questions in case you are shy here, right? I started way in the back row of this one just a few months ago. Okay, there is something put in chat. I'm just going to see if that's something.
Vish, can you
unblur my video? Really want to see me unblurred? Okay, let me try. Yeah, Cloudera office folks, nothing fancy happening behind. All right, so let me move on. And again, put it in the chat window if your folks are not, want to be vocal. But again, no dumb questions. Yeah. So, yeah. There is a dark side to this, right? Which is something we should know all about, because we are talking about a system, an ML system, which has been built by somebody based on their own data set, on their own data, on their own knowledge of how the system should be built. So what's the first issue? Data leakage is something that is going to be a huge one, right? So if you haven't seen this before, there was this big article done in Economist, and they talked about how usage of prompts and codes caused confidential data to be leaked. Most organizations are now very careful about this. So, but at the same time, I sort of think that, this is something you should pay real attention to if you're building and these systems for an enterprise, right? So it's one thing to say, okay, I'll use a large language model system to, write some code or book a ticket for, I don't know, Sri Lanka, right? And you can go to Expedia and it does it for you. But there is another one to expose your organizational data to build inferences with large language model. Don't do this, guys. The second problem is a more serious problem, right? You will see as you start using large language model, you will start trusting it so much and it will be so sophisticated in its response that you'll think, okay, it's everything it tells is right, which is not true. So here is, I'm giving it I'm taking a big large language model. So this is a Bloom LLM, which has been trained on a large data set. It has 7 billion parameters. So it's not a small model by any means, right? Very sophisticated model. And I write a simple query, write a history of United States one. And among all the information that it gives, the thing it gives is wrong, that United States is the largest country in the world. So you will see this, right? There will be lack of actual contextual understanding makes this makes model somewhat, vague in the responses. And sorry,
Vish, we have a couple of questions.
Yeah, sure.
In the chat.
Sure. Okay. Let me read up. Hey, Vish, I'm not audible anymore, hence sending a question. My question is, yeah, it was there. What has changed since November 22 post-GPT rollout? Yeah, the thing that's going to change, that's changed, that is the wide variety of applications people are starting to see and the sophistication of the model response. So the way, if you remember the first slide I talked about, where it's able to generate very contextual information for you based on the data you see. That's the first thing that has changed. The second thing that has changed is the ability of people to see the huge amount of benefit that they can get when they are able to deploy a model very quickly, right? So if you want to sort of, and we'll see it in one of the demos, right? How quickly you can build a system based on somebody else. So think of it like this, right? It's like somebody has built you an automobile, a complete automobile, right? It runs, it works, and it even gets you from point A to point B. And it is free in some sense, right? Not all, but in some sense it's free and it's given to you. Now you can take the automobile, change the color, and you are able to drive it and make it your own. So that's like one way to think of how it has changed. You can even change the automobile, like if you're a Transformer movie fan, and make it to do something else, right? So that's another option that you can think of. Let me look the second question. I have read that LLM is very energy intensive and as such constraints dev at organizations. So question is, LLM models is very energy intensive, absolutely true. And as such constraints development at organization level, also very true. It's not only energy intensive, it is infrastructure intensive. So the building, like I talked about, and I'll come to that slide or that details. And we'll talk about how hard it is to build one or create one from scratch, what kind of infra resources you need. But again, at the same time, if you want to implement it for an organization, how can you adapt it is the question here, right? So we will talk about that as well. So I'll cover some of this here, Arjun. All right. Thanks for this question, guys. Very interesting ones. Here's another issue or risk that you will see, right? So think of it, right? You are now taking this system, this automobile I talked about, and you are now driving it around in your company, right? That's what's going to happen. And if you build systems around it, you need to think about the risk. And this is one of the risks. So if you take earlier chat GPT and asked, should women be allowed to vote? It said no. And this is the answer. So this is common. Like, if you take another smaller model or try a model, you'll end up with some kind of sexist behavior or toxic content or content which children should not like to see. And it's not, if you're a coder, it's not something you can do by unit tests, right? How many different type of responses will you try to type in here to generate outcome and see them by hand or see them by eyes to vote? So there are ways to overcome biases. One of them is called as GADI or JD. It depends on how you pronounce it. It's identifying discriminated sequence generation, right? And that's where, again, I know I don't want to bore you with the theory, but look up GADI and it gives you there's a good paper around how they have implemented it, how they have removed toxicity, how they have identified biases and so on. So last one, if you were in an era born when I was born, SQL injection was a big thing, right? You could write something and put a SQL attack on it and write a SQL code on it and put it in a text box and you basically crash the system, right? And there is now an not Indian, but an equivalent attack on prompts, which is called prompt injection. And this is where one example of it that was fairly popular said you use a translator and you set up a template, but you set up the template and then you will screw the template by ignore the above directions, and then the French doesn't work because it just is not giving you basically messed up the system, right? So these are the things that you need to sort of think of also when you're building large language models. Another pause here for any last questions on toxicity before I move on to how do I now think of and take all this knowledge that I've sort of got in last 20-25 minutes to build one for my system, for my company, right? That's what we'll talk about now. Okay, so stop me again along the way. So what do you expect as the next set of use cases that is likely to occur, right? So it's here to stay. But if you are in this field or are wanting to be in this field and say, okay, I want to work on a large language model use case, what kind of use case will come? There are 5 or 6 different categories of work that's likely to happen in the next 6 months in most companies, right? That's my experience based on what I've discussed with my customers. One is simple content generation. So you give it a prompt, give me a history of United States, and it was going to you write, hopefully, the response, right? So you tell it an instruction and it give you a response. Let's flip it around. You have a financial document provided by an analyst. And this is, by the way, something, again, happy to discuss if you are seeing this with me offline, reach out to me, because domain adaptation and how do you take a broad LLM use case such as summarization and adapt it to a domain. So, for an example, one of my customers is in financial sales, and he has to read, or he or she has to read lots of analyst reports. And think about it, right? They decide on a trade strategy based on the information collected from 5 or 6 different reports, and the human ability to crunch this information is limited. So now a language model can take this information and provide you a summary, and it's not like, it's a very nuanced summary, taking into context things like the attentions I talked about, right? The attention models I talked about. So taking into context all the attention words and so on to give you a very nuanced summary on a large content. We all know, right? If you take Google Translator, or if you have not used it, recommend using DeepL Translator. These are all large language model use cases which are happening behind the scenes. The other information is information retrieval. And this is a very unique use case, right? And likely to be very popular. Customers I have met have a plethora of documents, invoices, customer contracts. They want to recognize some information just to understand some parts of the contract better than the others, right? So how do I recognize purchase orders of certain quantities? How do I recognize sales of certain quantities? So extract entities in the larger document is called as entity recognition, and this is another use case. Code generation is something just is coming all the time. If you haven't seen GitHub Pilot, go and have a look at it. You can just specify, generate a code for me to create table, and it will create a table for you, right? It will generate the DDL statement for you. So if we talked about this one briefly, I just wanted to get quickly reminded on this one. If we can build this one, why doesn't everybody build it, right? Why don't everybody take from 1 step to 5? Because this looks like a standard machine learning workflow. So the reason is here. To build a AI model, a large language model, is no mean task. It takes at least $3 million. And it's just not about money. It's also about the compute. So somebody, I think Arjun mentioned about the energy constraints and the compute constraints. So it takes up to 34 days to train GPT-3. And this is the number of GPUs. So A100 GPU, guys, cost thousands of dollars. One A100 GPUs cost thousands of dollars. And 1024 is needed for GPT-3. That was not even the latest GPT that we are talking about. So it's not a mean task. It's not something that can be done by everybody. And anybody who's worked in this field know that when you start training a model, you never get it right the first time. So what happens on the day 30, you have 4 days to go and you realize something's missing. You start again, right? So it's not a mean task. So what to do, right? How do I use it for my enterprise? I can't spend millions of dollars to train a model, and I don't have that kind of effort and skill. So that's where this whole lot of open source models that are now available come to rescue, right? So there are a number of large language models which has just been donated to the community, even for commercial use. So Llama 3 is a model which has been built by Facebook, and they are available for commercial use as of today, right? We don't know what happens tomorrow, but right now it's available. And these are open source. These are, the data it has been trained on, and you can understand what data it is, right? So it overcomes this big exorbitant cost we talked about in the last slide. And then you can take that and then you can start saying, okay, can I now tune it or tweak it to the specific data that I want and deploy it to production? So this is largely the direction the industry is heading in terms of how they are looking at model management on large language models.
And Vish, I unmuted here so the others can.
Sure, of course.
Can you go to the previous slide, please? Step 2, right? So how energy intensive or resource intensive is this thing?
It is very less energy intensive as compared to the main one. And maybe I can talk about 2 parts to this. So when you say fine tune or prompt tune model, there are more than one ways to do it. The simplest way to do a prompt tuning is not energy intensive at all, because you are not changing the model per se. What you are going to do is very simply similar to what I showed earlier, right? So if you remember, I told this is a horrible movie, sentiment is positive, sentiment is negative. This is a movie I liked very much, sentiment is positive. Use this, hey, large language model, use this template and now predict new ones. This is called as prompt engineering, prompt tuning. Now, this, I'm not using any extra energy. I'm just taking the same model and now adapting it more to the new context that I want to use. This is the most easy way to start using large language models in your own organization by tweaking it and bringing it inside. This doesn't require any energy. But what if I want to take that model and I want to now say, okay, I have a bunch of contracts I want to use, and this contracts I want to train it. Then what you are doing is you are tweaking the model to a very specific task. Again, there are lots of research that has been done on it. But long story short, there have been now approaches which allow you to tweak the model by using only 0.1% of the data or weights as compared to the original model, which means your energy consumption or intensity of training the model is also reduced to 0.1% of what was the original model. So this is much lower.
So you don't need a GPU to do this.
You need a GPU still to do this. You still need a GPU. But what you need is a very lower. So if you take the same example of GPT-3, GPT-3 was tuned at A100s with 1,000 GPUs. You can hear it, tweak it by using one GPU, and which is probably V100, which is the lowest class of GPU. You still need the GPU to do this. That's simply the life you have to now get accustomed to. That GPU is going to get tied closely to use cases for large language model. Can't escape it.
Thank you, Vish.
Hey, Norris. Good question. Right. So moving on, how do I now, the thing is, we saw how can you do 1, 2, and 3, but how can I now start, so to say? So the way to start is take a case of your own organization's context or knowledge base, and that's the starting point for enterprises that I've seen, right? So they want it very specific. It's interesting to know how to bring tickets to Sri Lanka on a general level, but how do I get access to a specific system? How do I know my own logs and can query on those logs is the larger question, right? How do I bring this enterprise knowledge base into a handshake with the system? While maintaining privacy. I don't want that knowledge to go out. I don't want that data to go out, right? That has to be kept private. And the way to go through this is to use open source models, in our opinion. At least at Cloudera, we are strong supporters of this format of usage because it allows you to control your destiny in terms of building the system. So, which one to choose? That's the second question. Like, there is a whole bunch of open source models which are available. I found this recommendation quite good. So based on which, so we already saw some code snippets with BERT model that I tried. These are smaller models with lower number of parameters. But then you have like something like Palm, which I talked about briefly, which has been trained on 540 billion parameters. And it can also tell you, based on this heat matrix, which kind of use case that you can use it for. So this is a good recommendation, I would say. So how do I start, right? If you have not heard of Hugging Face before, this is your number one source or repository for trying to learn and understand what models are, or also what NLP tasks are. So Hugging Face is a model repository or a publicly held model hub, which people are deploying newer and newer trained models or variants of model into for a wide variety of use cases. One of them is natural language processing. And you can now say, okay, based on natural language processing, I want to do question and answering, or I want to do translation. I want to do document summarization. You decide. And once you decide, you go to Hugging Face to sort of look at what kind of models are available. In one of the demos, I'll show you how we use this for text generation in Cloudera. Here, Ansari asked me one question. How easy or hard it is, or how resource intensive it is to tweak the models. I answered it at the highest level, but I'll tell you a little bit more here. So there are three ways in which you could tweak the model. You could tweak the model by a prompt approach. So you say, what is the capital of France? Depends on how sophisticated model is, it will give you an answer or not, right? But you can also use it to sort of make it understand a little bit more, make it a little bit like, not a great analogy if you are into animals perhaps, but a way to look at it is like, how do you teach your dog to treat, right? How do you teach your dog to fetch the stick? So it's a process of making a repeatable behavior and telling the pet that this is what I expect of you. So here's what I'm telling the pet, right? That the capital of Germany is Berlin, the capital of India is New Delhi, so what's the capital of France? And most likely it is now able to understand and interpret better and give you an output. And then there are more complicated ways of thought prompts, which I will skip for now, right? The second way is to do what is called as transfer learning. This is again a slightly deeper evolved topic, but essentially what it means is you take your source model and you use the weights of the source model and train it on a smaller set of data. So you get a great starting point because all the training process or all the learning process has already been done for you. And then you are now getting a head start in terms of training, right? And the third one is what, again, I can talk about a little, is how do you use a smaller data set but make it more augmented, right? And then these augmentations are used by the vector database. So again, there are, if nothing else, you can remember that there are these three broad approaches to make it more specific for your data set. So how do you decide how to adapt to your use cases, right? There are two broad approaches in my mind. Yes, you are getting a pre-trained model from this big matrix I saw color, the heat matrix I showed earlier. And you say, okay, if I give it a document, it is giving me a good enough response. You don't even need to do anything. Just use it, right? That's it. You're done, right? But in my opinion, in organizations, this doesn't work because the knowledge is so tactical to tacit to the organization that it sometimes is difficult for you to understand how to train the model, how to get the best out of the model. And that's where you will use some of these three tasks that I talked about to make it more context specific. And how does it matter, right? We talked a little bit about costs here. This is what I wanted to show you, right? So you should tune the model. If you take a pre-trained model and you say, okay, I want to pre-train something like this, even a variant of the model with a large set of parameters is extremely expensive to pre-train. But if you want to tune the model, right? And if you're tuning it with a reasonable set of size, the costs come down dramatically, right? So if you are in this space, even though it's quite expensive in some cases, based on the number of parameters, so the number of parameters, whenever you go and somebody asks you large language model, what should I choose? You'd say, you have to ask two things, okay? How big is your memory, and how large is the model, right? So each of these will, at the minimum, determine a lot of considerations, both in cost and in infrastructure. So some questions that are likely to happen, and you can ignore the CML workspace here. I was trying to demonstrate it for a client, but this will apply for you even if you are not in Cloudera, right? That how much should I be my RAM, right? So a model consists of weights, and each weight is the float vector. It's a float number, right? So if you go back to your, algebra days or whatever, it's a real number. And a real number takes 16 bits, that is 2 bytes. So when you are seeing a model which says Bloom 7B or Bloom 1B, the 7B is the model parameters that you will fit in memory, which means for a 7 billion parameters, you need a 14 GB memory because each is 2 bytes, and 7 into 2 is 14 bytes. 14 billion bytes is 14 GB memory. This is only to fit the model, right? It's not holding the data per se that you are talking about and other things. It's only the model that is in memory. So at the minimum, you will need a 14 GB memory, and that's why you need a GPU. Yeah. So do I always need a GPU? Most times, yes, you do need a GPU, because even if you are training, there is absolutely no real way you can train in a CPU mode. You'll run into a lot of timeout exceptions. there are some complex topics I don't want to touch here. It's called sharding, which will shard your data set in the memory or model weights in the memory, so that you can go through it step by step, put one in the disk and then bring it to the memory and so on. So look it up if you are trying to go into this topic a little bit more. The last one is important, that you are able to take large models and so float is 2 bytes, but you can take and change the float. So 2 point, let's say 1, 2, 3, 4, take that number, a real number, which has 15 digits after it. And you can also say it's 2.1, and that's an int2. That's an integer, right? That may be good enough for in some cases. And that is called as the quantization. So you quantize it from float to integer, and that way you can reduce the memory size. There are also a mixed mode operation where you can use a CPU and GPU, but again, complex topic, warning, lots to read here. So far so good. We have looked at a lot of slides, but let's look at some reality, how all this looks. So I'm going to show some demos, but any questions still now on what I showed so far?
I have one question.
Yeah.
So we slightly touched on sharding, but we didn't go any deeper for good reason. So is it with sharding that we use a lot of GPUs, or is it something else?
Yeah. So fundamentally, what is sharding, right? It is called slicing. So what you are trying to basically think of is, if you are taking a large language model, there are a number of layers in which a model is. Think of a model like lasagna, right? It has a number of layers of sheets. The inputs is on the one side and the output is on the other side. On each of the sheet of lasagna is what you have weights, right? And now what is happening is, when you are doing sharding, you're saying, I'm not, so take the Llama model, or now GPT-4 model. Now it's a trillion parameters. Imagine the kind of memory and GPU. Maybe the GPUs are not even built like that. Now they have custom built these GPUs, right? So how do I use this model? I want to use that kind of model. So what it does is, it's like taking, you have now a smaller cup, right? And you're taking one sheet of that lasagna and putting it into that cup, and basically layering the lasagna and moving it off to the next cup before moving it to the oven, and then you're taking in one next sheet of lasagna. So the sharding is very simple. It's similarly, like, you're cutting the lasagna into multiple layers, cutting the model into different slices, taking one part of it into the disk, and taking the second layer into the memory, so that you are now having a much more smaller layer amount of thing in memory. You're working through that weights, putting it back into the disk, moving to the next one. And that way your GPU memory is able to accommodate the number of weights or one sheet of lasagna, right? So that as a paradigm to compare. And that's how sharding really works. But the bottom line is what you talked about, right? It is used to do memory management much more effectively, especially when the size of the parameters gets very large. The three things to think about, right? We only think about, oh, this is my model, 15 billion, 30 billion parameters, but that's only one thing. The model has to do something. So you have to giving it a string to do text classification or generation. All that information has to be put in memory. So that's the second aspect that you have to create in terms of the string that you are holding in memory. So that's the additional memory requirement. Imagine large documents that needs to be translated or summarized. All this will go into the memory of the model to work. The third aspect is, if you remember way back, I covered vectorization, where we talked about models, large language models do not understand languages. So they need to be converted into vectors. All these three characteristics are together required for a model to work. We think of only the model. So that's why fitting into the model into memory becomes the number one headache in overall large language model production deployments. Long story short, but that's why the shiny comes into the picture.
Okay. That brings me to my next question.
Yeah, of course. Do we have some time? So
yeah. So to train a model, we need GPUs. To fine tune a model, or to even prompt tune a model, we need GPUs. Do we need GPUs to run a model?
Yeah. You need, even for inferencing a model, you need GPUs. Because again, let's take this very simple case of a 30 billion parameter model. A 30 billion parameter model with float 60, even if you are using like the model at its basic sense, it floats 16, is 60 GB memory. 60 GB memory can't accommodate, right? And then imagine the computation the model has to go through. So not all this is the answer. It depends on it depends is the consultant answer. That it will depend on the use case that you're trying to perform. So there are large language models which are 1 billion parameters which you can try to fit in memory. There are techniques like quantization which allow you to still fit in memory for inferencing. So 3 stages. Training, definitely you need, can't get away. Even for fine-tuning the model, you will need, even depending on the model again you use, but any sophisticated model you will need. Increasingly, inferencing can't be done. Even in fact, the demo that I'll show you, you need at least 1 GPU. The thing is that these are like, people think of GPUs like, okay, it's going to be always expensive, not necessarily. Like nowadays, GPUs are for commodity hardware, especially being made. So the V100 GPU on AWS for, I think, 13 hours of 12 hours of training for me cost $4. So it's not bad, right? So you can still do it. Okay, so 2 demos and how to look at this as a system. One is the most serious demo, which we are using in Cloudera to sort of show the easiest implementation of a chatbot that you can do. And again, it is not a general chatbot. It's a chatbot for enterprise data. And I'll walk you through. So any folks here, like, I don't know how many members are there. I don't see number of people. 20. Okay. Can folks here tell me, just type in, can you understand Python code or not? Just quickly type so that I get a sense of yes or no. Just say yes or no. And then I get a sense of, okay, how big the audience is who don't understand Python, and I can work fast and slow. Okay, just give me a summarize. I'm sorry when you get it.
Yeah, sure.
I mean, at a high level, I don't need a very specific. So about 50% who understand code, 50% who don't. Okay, good. So about 50% understand code, 50% are so not so code deep. So guys who are not who understand code, sorry, I will not do a big code walkthrough for you guys. But I promise you, this demo we'll do it like this. This demo I will do it a little more visual to talk about how you can use large language models. And then the next demo, the Sherlock demo, will be like a fun demo. Let's do a little bit code fun there to look at how it works. So this is, by the way, Cloudera Machine Learning. This is part of the machine learning suite of services that Cloudera provides. Again, this is not a Cloudera session, so I'm not going to spend too much time here. But this is better. Yeah, so this is Cloudera Machine Learning, and this is a machine learning workbench for setting up your ML projects and doing your ML workflow. This is just for some information. Again, reach out to Ansari if you want to know more, or me. What I'm going to do is just focus on the LLM topic here. So this is my code for building a large language model. I'm going to do a couple of things, right? Just for the benefit of some folks here who are a little code savvy, that I'm going to explain to you what's happening here, right? So here we are doing like an augmentation of enterprise data, right? So if you take, like, for example, what is Iceberg as an example? Typically, you will get a typical from a large language model, which has no understanding of context. It will give you a typical example of what is an iceberg, right? Whatever it is. Now, in case of Cloudera, iceberg is a table format, right? It's a kind of a database table format. And we want to make sure that the large language model is able to provide this level of enterprise context. So when we tuned this model, we used our enterprise data to tune the model to make it understand what is happening, okay? Another thing to understand is the model to use. So when I talked about using third-party models or other large language models from Hugging Face, this is what I mean. So if you go to a Hugging Face website, let's open one. And here, like, okay, this is where I'm not going to explain the Hugging Face website to you, but this is how the models are available for you from Hugging Face. So, for example, our model is an H2O variant of a GPT, and 512 here tells me like, they have changed this, but they have changed the model from 512 to something like 6.9 billion parameters. So it's explaining here in the model card that it is a large language model and it is licensed for commercial use. More zoom? Yeah, sure. No problem. So it's a large language model, and this is how you can use it for commercial use and so on. So this is the playground that you have, and you can also, it gives you lots of information here, how to use the model and so on. So this is what we have used to build our first model. And I think it's important to show a little bit on here what is happening, right? Why is it able to give you like a much more nuanced contextual information when you use the large language model and tweak it with enterprise data as against having no context, right? And the way it works like this, if you remember, I covered briefly the vector database, right? That vector database, it provides you contextual information, boys to girl, king is to queen, those sort of things. And this is where we plug in the model with the contextual information. So the user asks a question, what is iceberg table? But instead of, so one aspect is you go directly and give it a generic response. But when you are giving it a question, it is doing, it is using the organizational database to convert it and put it into a vector data. And so when you are querying it, it is creating, just like we talked about the king is to queen and so on, it creates similarity, it creates richness in terms of the prompt, so that when you get an actual response, it is a much more factual response that you get. So in case you want to know a little bit more what this means, right? Again, so please be understanding here. We are not training any model here. We are also not fine-tuning the model. Okay, this is just prompt enhancement. But we are just trying to give it a more wider, better understood prompt to get a better understood response, right? So this is basically done using what is called as a RAG architecture, retrieval augmentation generation, which can be read here. I will put a GitHub link to this in the after the workshop on the posts or something, so that you can read a little more about this. But this is typically the approach, so that you get a better augmented response for your query. So the requirements for this to run is 1 GPU and 16 GB memory, and then 2 CPUs, right? So and so on, other project structure. So the long story why I wanted to show this is how the structure of a typical enterprise implementation of a large language model can look like, right? And then maybe very quickly, one or two things from code that may be important. Let me go to the data is here. So yeah, the data will be interesting. So we talked about data augmentation. So here is some augmentation data that I used. So I used some augmentation on Iceberg. So that's why you see, Apache Iceberg is an Opal table format, Now what is happening here, right? This is just textual data. And you are just, if you want to change this and apply this for your own organization, just need to make textual data available in some kind of a file format, like TXT or whatever, and you're good to go. You're not trying to do any training. You're not trying to do any labeling, nothing, right? This is simply textual data. And the more context you provide, so I can do this we have done this for ozone. What is ozone? And it gives you a better nuanced response. So what I'll do is I'll quickly show first the output, and then we will look at a little bit about the code, right? So that it gives you a little more feel of what's going on. So it is deployed as an application in Cloudera machine learning. So when I open the application, it looks something like this, right? So for the more tech savvy among folks, this is built with Gradio, depending on how you pronounce it. And Gradio is now like, you can go and check it out again. It's one of the, very cool tools that have been built for all sort of ML projects, right? So if you want to quickly show to your users what you are building, you don't need to know ASP. What's the programming language paradigm? ASP.NET or whatever. Yeah, exactly. Or even, Python frameworks are not easy to generate, right? So this is like Streamlit or any other simple application for building it. So now, if I remember, we saw two things, right? We talked about Ozone, we saw runtimes, those kind of things. So if I ask it, what is Ozone, right? And I submit it. So it will now think a little bit because it's again processing the word. What is happening behind the scenes? Let me go back again to here, to the home overview. So my question is, what is Ozone? It is now, one aspect is directly going to the model. The second aspect is going to the vector database. This vector database has been sort of inputted or inserted with contextual data. So if you remember, I showed you files with Ozone, files with Iceberg. So that knowledge base I have inserted here, right, in the vector database. And when I ask it what is Ozone, it is going and querying the knowledge database and coming back with the right contextual information and creating a new prompt. And this new prompt, when you go and deploy it, it is giving you the right response. So when you ask it without context, this is the hallucinated, and this is the term you will keep hearing a lot, which is called as a hallucinated response. So the hallucinated response is not important or not useful. Ozone is a molecule, 3 atom, blah, blah, blah. I don't need this for my organization. But for my organization, Ozone is a key value store that is using big data workloads, right? So it is available in CDB private. So again, I have not trained the model on anything. I have just created files and updated the model to provide a more enhanced response. And that is given me an output. And how we do it, let me quickly touch upon some code files. So you just do some installation of dependencies, and then you do some model downloads. So let me show you one of the scripts. So if you remember, we saw this model card here, right? Hidden face model card. This is the model card. H2O AI, that comes here. This is my model that I'm getting from the repo. And remember, there is always, I talk about, we think about LLM model as the only model. It's not true, right? The model is also having another aspect, which is converting the tokens into numbers. That is the embedding. So these are the sentence transformers, which is the embedding model that is required to convert and provide vectorial representations for your words. And so this is the two things that you need to get started. And then after that, there are some curl commands to bring the model down and store it into specific areas and set up the model. So this is how you will start with download of the model. And then the third aspect is the population of the vector database. So once you get the model, you populate a vector database. I think we talked about this weekly, if you remember, the vector database, king, queen associations and so on. So this is where all the population of the vector database happens. Again, too much code. I'll not talk more. And when you hear vector database, there are different formats, Milverse, ChromaDB, and so on. But this is a very simple, the very basic implementation without fine-tuning of a large language model with augmented enterprise data, right? So I'll pause here now. Very happy to go through any other aspects, answer any other questions. I would like to use the 9 minutes. I can show another demo if required, bonus demo, or we can talk a little more. And people can share any other experiences as well. And there are some questions as well. Let me open the chat. Any questions so far? People can just unmute themselves and ask. It's been a long presentation and some demo, but if there is any questions. No questions? I haven't hopefully put people to sleep. Too much theory, too much math. But one encouraging responses. I saw 19 participants and now only one's left. So that's good enough.
Kapil, any questions?
No, you're putting people.
Yeah, I just
He was excited to join.
Hello.
I'm hearing you.
Yeah, I'm audible.
I can't hear him.
Hello.
Yeah, Kapil.
Are you able to hear me?
Now we can.
Achha. So I had just one question. Basically, I was searching about it. I found that there is a platform called LangChain.
Yeah.
So can you please tell me more about it, because I have...
Well, asked his question.
Hello?
Yeah, keep going.
Yeah, so I just wanted to tell me more about it. Like what does this platform do? How it can help us to build uh, applications based on LLM?
So maybe just to talk about LangChain, right? I mean, LangChain is a framework, and it's called language chaining, basically, right? And what it is used for, and we didn't go too deep into how we are building prompt, right? I sort of touched upon it briefly, but how LangChain basically works is you can use it to do sort of prompt chaining, right? So you can say, okay, if you remember when I talked about the prompts in the LLM context, we said, okay, think like a 5-year-old.
Yes.
You're telling the prompt some instruction. So LangChain provides you an easy way to sort of change your set of prompts, and so that you can always provide an effectual response, or you can order your prompts in a certain way so that it can teach the machine learning system better. I can give you one example also. Maybe I can have my mouse back and I can show you. So, yeah, I'll make the font size bigger. Is this helpful? Yeah, so let's look at, I wanted to sort of demo some things today. So here's one easy file to use, how you can set up LangChain. And maybe I use that to sort of show you something I had in mind on showing, and which is how do I build something fun with LangChain, right? So here is what we are trying to do. Where is my presentation?
So you have also built upon
Yeah.
the language.
So how do you prompt like Sherlock, right? Like, so if you have like, I'm a Sherlock Holmes fan, and what I did was I basically took in Project Gutenberg, the entire Sherlock Holmes files are available in internet free of charge. I took that and now started feeding it into a large language model, and then I wanted to query the book, like, so to say, like I'm querying Sherlock Holmes, right? So I want to do something fun like that. So here's what I did. I used LangChain to do this kind of document retrieval, retrieving. And I used ChromaDB. So ChromaDB is like a vector database, right? If you remember all the vector database conversation we talked about. And this is going to take some time to set up for GPUs and other things, but I have the code sort of answers here. So how do you set up this? So typically, so Transformers is sort of your library for working with Hugging Face. So Hugging Face provides the Transformer library for working with models. Here I'm taking, if you remember, an open source model, Vicuna, with 7 billion parameters. And from pre-train, just tells me, give me a handle to the model. That's all, right? And float 16, you remember all these conversations we had about float and integers and what kind of memory and so on. I'm telling it, hold the memory in float 16, right? That my GPU can accommodate it, okay? And then you sort of build the pipeline. And again, this is traditionally a way to query large language model. And that's what we will do now, right? So first of all, I just take the typical pipeline, which is typical model that I have used here, got here. And I ask it a question like, how are you doing today? It is going to give me a response. I'm doing well. Thank you for asking. All these things, right? Now, LangChain, how to use LangChain. So what we'll do, we will take Sherlock Holmes and say, give me the entire Sherlock Holmes as an EPUB document and load it, right? And now here is where I'm using LangChain framework. So unstructured EPUB loader. This is one of the things. You don't have to, this is one of the things that LangChain provides. It's an easy way to work with large language models by using different kind of loaders with different kind of interfaces. So here I want to use an EPUB loader to load the entire Sherlock Holmes into as an object. When I load it, then I have to split the data. Remember, like, everything in language models is about splitting, converting it into tokens and so on. So I'm splitting the data. Again, LangChain provides me a very convenient way to split the data, which is the recursive characters text splitter here. So then let's look at some data here. So if you are a fan of Sherlock Holmes, then you will know this is his reference to Irene Adler. That's the only girl Sherlock Holmes ever liked in his life, or considered his equal. So that's, we are able to see some text associated with Irene Adler here, right? So those sort of things. Then you create some database, and this is the vector database that we created. And then finally, using the LangChain, right? Now, again, you're training from chain type, you're telling it a format. What are you telling it? I'm giving you some context. Please take this context. I'm giving you, when I give you the question, provide me an helpful answer, right? So this is my template. And this is where LangChain comes in. It helps me set up my data in a sort of template. I'm almost going over time, so I'll just a couple of more minutes to answer. So when what is a template now, right? So if you remember, there are three things: context, question, answer. So my context is, my name is Sherlock, you are Sherlock Holmes. So the model is a Sherlock Holmes now, right? Use this context to answer the questions. If you don't know the answer, just say don't know. Don't try to, give some garbage answer. These are my instructions. So the context is an instruction. Then the question is whatever I'm asking, and answer is this, right? So now let's, I do a lot of processing here. So here, I'm now giving simply the question. My question is, in which case was Sherlock Holmes involved with royalty, right? It's just like asking, perhaps like me, right? Sherlock Holmes fan. In which case was he involved in royalty, right? Prior to setting up the database and other things, it had no clue about Sherlock Holmes, or maybe it was one of the hundreds of documents it was trained. Now it is tuned very specifically for being like Sherlock Holmes, right? So it's able to give me an answer. It's the king of Scandinavia, right? That's the case in which Sherlock Holmes was involved, only case in which he was involved in royalty, right? So how did Sherlock Holmes know that Dr. Watson was earlier in the army? Like he guessed, right? He sort of saw Dr. Watson and said, you are in the army. How did he know? He know that there was a scar in the waist, So it's giving an answer as Sherlock Holmes. So again, the question is Dr. Watson. So it's answering, look how accurately it's answering, right? On this data. You can frame any query, and it's on Sherlock Holmes, it's going to answer. Were Sherlock Holmes and Dr. Watson friends? Yes, they were friends. How about Dr. Moriarty, right? Moriarty is like his arch enemy, right? So were they friends? And it's able to guess, right? No, they were not friends, right? And what was the hardest case for Sherlock Holmes to crack? Again, it's a very nuanced question, but it's able to determine based on some logic that what had caused the man to be insane, right? What were some of the popular cases? Again, it's like asking a friend, right? A study in Scarlet, the Hound of Baskervilles. So it's like asking an expert or a friend what it is. Who was the villain? So it got this one wrong. Charles Baskerville is not the villain. This one was wrong, actually. So who are the characters in the Sign of War, right? So it's, as you can see, the LangChain has been used to chain these responses together, to provide it a context, and to load the EPUB loader from Sherlock. So this is how you would use LangChain, Kapil.
Okay. It looks good. I can see a lot of configurations happen in it, and I need to understand all of that. Too much information.
It got some things wrong. Yeah. In fact, it says Dr. Helen is one of the Sign of War, which is wrong, right? This is not. So yeah, that's pretty much winds down my talk for today. I wanted to leave with one last slide. I think there were some customer use cases I wanted to talk, but it's not important. But this is, I think, what we should end with. How do you use your machine learning systems, right? You just need to stir the pile. All right. Thank you, folks. Thank you for listening. I think I was slightly overshot time, but I hope this session was useful. And if I'm happy to stay on for a few more minutes if there are any further questions.
I have like one more question. Like, is there any open source projects are going on in this? Do you know about it so that we can look into it?
Open source? What? I didn't get the question.
Okay, any open source project based on the LLMs or on the top of LLMs which are going on? If you know about it, you can share that information so that I can look into it and maybe I start contributing over there.
Yeah, a couple of them. Like I think LangChain is completely open source. You can contribute to LangChain for sure. If you go to Hugging Face, lots of things are happening in Hugging Face space in terms of how they are doing model development. Again, it's very broad. This space probably has more things going on in open source than anything else. If I take the question and take it a step forward, what's the big problems that people are trying to solve that open source community is directed towards is adaptation. Like how do I adapt models for specific use cases? So I briefly touched upon it, but if I have like a financial data set, I want to adapt the model to for financial data set. Or if I want to adapt the model for image plus text data set, how do I adapt? These are the areas where people are trying to solve problems by making like all the plumbing's hard, like LangChain, right? LangChain's done all the plumbing so that you are now able to quickly write instructions and tune the model to your needs. So that's where a lot of work is happening. Like, so check out Transformers. They have lots of things going on.
Yeah, thank you.
Welcome.
Vish, I have one question. Any Gen AI assistant application you have used?
I used not in reality to completely end to end. So I used even in this. If you saw all the pictures that I made with the piano, the boy opening the window, they are not readily available. Like not the way I wanted. Well, I used I think Medium or Picasso Web to generate those images for my need.
Okay.
So that were my example. I didn't build any videos or anything, and I tried once trying to booking a ticket on Expedia, but I didn't trust it. So to be honest,
I know question was directed at Vish, but I have used Stable Diffusion, and it's a lot of fun. You need to have a graphics card to run Stable Diffusion, though. It's fun.
Yeah, thank you.
welcome.
Any other questions, guys, before we wrap it up?
Any courses on this prompting which you can look at? Means if I want to improve on prompting, so is there any course or something?
Yeah. I mean, again, so there is no science to this. This is all evolving, but look at just check out again Hugging Face. Even OpenAI have written blogs on prompting and so on. Yeah.
There are a few courses in Udemy about prompt engineering, in case you're interested.
Thanks.
Thank you. Thanks for your question. Thank you for your questions.